So our goal for this video is to kind of go through some different trig expressions and using our fundamental trigonometric identities to simplify these expressions. So the first thing you want to make sure you have out is your fundamental trigonometric identities notes, or you can also find these right in your textbook online. So our goal is to take these identities and use them to substitute into a given expression like this one here to simplify our answer. So if I have this expression, the first thing I'm really drawn to here is both the numerator and denominator, because I recognize parts of the Pythagorean identities. If I was to take a look at my first Pythagorean identity on our sheet, I get sine squared x plus the cosine squared x is equal to 1. And if I was to subtract a sine squared x from both sides of my equation here for my identity, I would get the cosine squared x is equal to 1 minus sine squared x. And this is so important because what I have now is this part here matches the given expression. So whenever you see that match, you can make a direct substitution. So now, instead of writing 1 minus sine squared x, I can make that substitution and instead write the cosine squared x. If I take a look at my denominator, I'm looking at the function, I'm looking at the trigonometric identity, Pythagorean theorems again, and I'm looking at 1 plus the cotangent squared x is equal to the cosecant squared of x. And if I take this initial expression and I subtract 1 from both sides of this identity, I get that the cotangent squared x is equal to the cosecant squared x minus 1. And again, this is so important because I can take this and see this direct substitution. Here I have the cosecant squared x, and here I have the cosecant squared x minus 1. So because those are equal to each other, I can make that direct substitution and now go ahead and write, instead of cosecant squared x minus 1, replace it or substitute in the cotangent squared x. Now I'm going to go ahead and do some more substitutions using my reciprocal identities and my quotient identities. And I know that here, if I have cosine squared x, there's not much I can do with that. It's just cosine squared x. But if I have the cotangent squared x, I can rewrite that. So now I have the cosine squared x all over the cosine squared x over sine squared x. From here, my cosine values will cancel out, and I will be left with a sine squared x. Now the math behind this gets into just complex fraction work and fraction within a fraction. So to see how that all simplifies out, remember this is going to be the cosine squared x all over the cosine squared x over sine squared x. You're probably all most comfortable rewriting this as the cosine squared x times sine squared x over cosine squared x, and from here you can really see why those cosine squareds are canceling out and why you're left with a sine squared x as your final solution there.